students, in this video we're going to be going over lesson 17 regarding single discounts. This lesson focuses on calculating discount amounts and finding the amount due after subtracting the discount. It also uses the discount's complement to find the amount due. A discount is a reduction in the price of an item. The discount is usually expressed as a percentage rate. A trade discount might be offered for buying in large quantities from a vendor. A cash discount might be offered for prompt payment. I'd like to direct your attention to the top of page 104, where an illustration of the terms that might be offered on an invoice is shown. Notice that the terms are expressed as 2/10, N30. What that means is that a 2% discount will be given if the invoice is paid within 10 days from the invoice date, but the net amount is due in 30 days maximum. So they're offering a discount in this case if you pay within that 10-day period. Let's take a look at the handout available to you on the Canvas site, where we're going to look at some demonstration problems in calculating these kind of discounts and the options that are available to us in calculating these. First, let's take a look at page 104 and 105. We're going to look at the demonstration problem that shows that the invoice total is $2,021.92. We're going to figure out the amount of the 2% cash discounts that's being offered, and then what the amount due on that invoice would be after that discount. And we're going to do it continuously. So we do that by putting in the price of the invoice times, and here we're going to actually use this percent key. So we input 2 and we use the percent key. That calculates the amount of that discount. And then by using the red minus equal key, the discount will get subtracted from that amount and tell us what the new amount due would be. So you can see that your handout walks you through that calculation. This is what your tape should look like when you're done. So we've calculated both the discount and then subtracted it and gotten the new amount due. Let's take a look at page 106 and 107. Here we have a list price of $3,980. They're being offered a 40% trade discount, and they're also being offered, as you can see from the terms of the invoice, a 3% discount if they pay the invoice in 30 days. So we're going to be calculating the trade discount, the new net price, because the cash discount would be based on the net price, not the list price. Then we're going to calculate the cash discount, subtract that, and find out our amount due, all in a continuous fashion. So let's do that. First, we input the list price, $3,980, times, and we're going to use the percent key again here, 40%. There's our discount, and we're going to use the minus equal key here to subtract that, and this then is our net price, $2,388. Now that net price is going to be taken times the 3% cash discount. Use that minus equal key, that will subtract the cash discount, and we have now arrived at the amount due for that invoice. So this is what your tape will look like. You've done that in a continuous fashion. You've gone from list price to the amount of your trade discount, subtracted that, arrived at net price, figured out your cash discount on that net price, and now you have the amount due for that invoice. Now I'd like to turn your attention to page 107. Again, you do have a handout available to you that I'd like you to consult for this, because there are two different ways that this problem could be done. There's the methodology that I just showed you, which would be using the percent keys and this minus equal key. Another way of doing this would be to use the memory keys. So let's go over this method 1 and contrast that with method 2 that we've just done. So method 1 starts out, both of these start out doing the extension on the invoice to arrive at list price. So we're going to take quantity times price. We've done the extension. This is the list price. We're going to put that in a memory as a positive. Then we take that times our trade discount. Now in this case, we're going to convert the 40% to its decimal equivalent, 0.40, and we're going to put that into the calculator. And now that discount needs to go into memory as a negative. When I subtotal memory, I have my net price. That net price then is going to be taken times the decimal equivalent of 3%, or 0.03. And that gives us the cash discount. Put that into memory as a negative, and now we total memory. So we've just done the same problem using the memory keys. This is what your tape should look like when you finish that. Either method is acceptable. I think you need to figure out which of those methods seems to be most comfortable for you and use that method in doing your invoice problems. Hi students, in this video we're still focusing on lesson 17. We're going to discuss and do some problems using the complement of a discount. So I'd like you to turn to page 108 and 109 of your text, and let's do demonstration problem C on 108 first. We have a list price of $1,882. What we're going to do in this first demonstration is we're going to be using the constant key. So we're going to engage the constant key here. We're going to input the list price times 30%. That gives us the trade discount. Then using the complement of that trade discount, if the discount is 30%, the complement would be 70%. So now we're going to input 70% to calculate the net price. Now we want to remove that constant key. We're going to take that net price times the 2% cash discount and basically subtract that from the net price. So that's how we produce the tape that you see in that handout. By engaging the constant key, using it to calculate the trade discount, then using it to calculate the net price using the complement, taking that net price, calculating the cash discount, subtracting that from net price, and arriving at amount due. Let's look at the problem now on 109. Again, we're going to engage the constant function. We will take the list price of $250 times 30%. That's our discount amount. Then we're going to take that same list price, which we've got in there as a constant now, times the complement of 70%, and we arrive at net price. Hello students, this video is going to cover lesson 18, series discounts. We're going to be using complements to find the net price. Businesses are sometimes offered more than one trade discount. A series discount might be expressed as 25% and 10%. This doesn't mean a total of 35%, but that 25% is deducted from the list price and 10% is deducted from what's left. Let's take a look at the demonstration problem on page 111 to illustrate how we use complements to find the net price. First, we're going to make sure our calculators are set at 2, the decimal is set at 2, and it's in the 5/4 position. So the first thing we're going to do is enter the list price. The list price in this demonstration problem A is $721.80. So we're going to enter that list price and we're going to multiply it times the first complement. The discount is expressed at 15%, therefore the complement is 85%. We're going to enter 0.85, the decimal equivalent. And that would be then our first reduction. Then we take that amount times the complement of the second discount. If the discount is 10%, 0.90 is the decimal equivalent of its complement. We enter that. Then we take that answer times the complement of the third discount, which is 10%. Again, the complement would be times 0.90. And that's how we have found the net price using complements. Here's our list price, the first complement, second complement, third complement, and our net price. Hello students, this video is for lesson 18. We are going to find the net price and the discount amount using the memory keys. So turn to page 112 of your text and we're going to do the demonstration problem B. We're going to be using the blue memory keys for this problem. The first thing we're going to do is enter the list price into memory as a positive. Then we want to take that amount and multiply it times the complement of the first trade discount. The first trade discount is 5%, therefore the complement would be 95%. So I'm going to take that and multiply it by 95 and hit the percent key. Now I could have used the decimal equivalent and input times 0.95, that would have worked also. Now I'm going to take this answer times the complement of the second discount. The second discount is 2.5%. The complement would be 97.5%. Now that answer is going to get entered into memory as a negative, and then I am going to total my memory. So what I have here on my tape is I started out with the list price. Then I input the complements of my discounts. So I ended up here with net price and here with my discount amount. So if you look at your tapes, you started out putting list price into memory. You then multiplied it times the complements of your series discount. Then you put that amount in as a negative into the memory, which then allowed you to total what the discount amount was. In other words, if this is list price and we subtract then our net price from it, we are left with what our discount amount is. So hello students, this video is for lesson 18, and the operation that I'm going to demonstrate is continuous operations to find gross price, net price, cash discount, amount due, and trade discount. This can be found on page 113 of your text. I'm going to demonstrate how we calculate these using the memory keys. So the first thing that I'm going to do is to do the extension on the invoice. And that is that we need to take the quantity of 50 and multiply it times the unit price of $99.95. That gives us $4,997.50. I want to put that into memory as a positive. Now I'm going to take that gross price and multiply it times the complement of the first trade discount. First trade discount is 30%. So the complement would be times 70%. Then I'm going to take that answer and multiply it times the complement of the second discount. Second discount is 5%, complement would be 95%. Take that answer times the complement of the third discount, which once again would be 95%. So what I've calculated at this point then would be the net price of $3,157.17. I'm going to enter that into memory as a negative amount. Now, the next thing that I want to do is compute the cash discount. So I am going to take my net price and multiply it times 2.5%, the cash amount. Now what I want to do is I want to subtract that cash discount from the net price. So I'm going to enter it with this red minus equal key. And that then allows me to compute the amount of the invoice that is actually due. Now, if I enter that amount, or excuse me, if I, in addition to that, total my memory, I will also be able to have continuously calculated the trade discount. So what we have here on our tape then is that we've gone from gross price, we have entered that into memory, as you can see here. Let me move the tape up so you can see perhaps a little bit better. So this gross price went into memory. Then we multiplied that amount times the three complements, which gave us what the net price was. We put the net price into memory as a negative. We took the net price, multiplied it times the cash discount, subtracted the cash discount from that amount, and came up with what the amount due on the invoice would be. Now, because we've put gross price and net price into memory, when we total memory, we are going to get the discount amount. So what we have done is we have used continuous operations to find the gross price, the net price, the cash discount, the amount due, as well as the trade discount. Hi students, this video is demonstrating another concept from lesson 18, and that is how to calculate a single complement for a series discount. So let's assume that we're dealing with a series of discounts, 20%, 10%, 5%. We convert those each to their complements, 80%, 90%, 95%. Now what we're going to do is convert those series to a single complement. We do that by simply multiplying these complements. 80% is 0.80 times 0.90 times 0.95. What we've done is we've simply multiplied those complements together, and we've gotten a single complement, 0.684. Now, there's a table in your textbook on page 115 that shows you how these single complements could be put in a table. In this particular table, if you looked up the first discount of 20% in the column heading, and then you followed the rows down to the 10 to 15% row, and you find where they intersect in the table, you'll see that 0.684 is the table single complement for a series discount. That's what we got when we just calculated it ourselves. So it's two different ways of coming up with the same amount. I'd like you to be able to calculate them either way, by using the calculator itself or by looking the number up in the table. Hi students, this video focuses on some concepts brought out in lesson 19, extending invoices and quantity pricing. When you multiply the quantity of an item on an invoice by its unit price, this is known as extending the invoice. Once an invoice is extended, the extensions must be added. If any trade discounts or sales tax apply, they must be subtracted and then added, respectively. I want to bring your attention to the fact that in this particular lesson, there's a number of quantities that are used in relation to invoices. A gross is a grouping of 144 items. A ream is a grouping of 500 sheets, generally used in paper. The Roman numeral C stands for a grouping of 100, the Roman numeral M for 1,000, and then dozen is 12. So you need to know these quantities in relations to invoices, and I want to just make sure that you focus on those groupings because they're frequently used, particularly when ordering things like office supplies. Let's turn to page 119 in your text. I'd like to demonstrate this particular problem using both the grand total and the memory keys and showing you how we can continuously calculate the particular amounts on this invoice. So I'm going to set my calculator so that the grand total function is engaged. I'm going to leave the decimal at 2 because I'm dealing with dollars and cent amounts. And the first thing that I'm going to do is calculate the extensions on the invoice. So I have a quantity of 12 times 37.75. That amount is going into the grand total. Then I have a quantity of 24 times 498, 36 times 1250, 24 times 250, 8 times 36.99, 6 times 14.95, and 6 times 9.75. So I've got all my extensions in there. Now I'm going to press the blue grand total key so that I get my total invoice price. Now I'm going to put that invoice price into memory as a positive. And I'm also going to take it and multiply it times the 3 complements of the trade discount. So I'm going to hit the multiplication key and put in the first complement, 0.80, times the second complement, 0.90, times the third complement, 0.90. This has given me the net price. I'm going to put the net price into memory as a negative. Now I'm going to take that net price and multiply it times the sales tax amount of 5%. So I'm going to take that times 5%. That gives me the sales tax amount, which I am then going to press the not the minus equal key, the plus key, because sales tax gets added to that amount. So I'm going to add that sales tax to get my amount due for the invoice. Now, if I also hit the memory total key, I get my discount amount. So notice that our tape here is showing all of the extensions that we did to get to what is our invoice price. And we did that using the grand total function. Then we put that invoice price into memory. And we went on and calculated, using complements, what the net price would be after those discounts. We put that net price into memory as a negative. Then we took the net price times 5%, which gave us the sales tax. We added the sales tax onto the net price to get our actual amount due. Then, by totaling the memory, the invoice price was combined with the net price, and we then were able to calculate the discount amount. So we have done that using the grand total function, using the memory keys, and calculating it continuously. This is video number 36, extending items priced by dozen, ream, hundred, and thousands. Hi students, I want to go over a concept with you from lesson 19 regarding extending items that are priced by units, like by the dozen or the ream or the hundred or the thousand. So please turn to page 123 of your text and let's go over the first couple of demonstrations. Here we're quoted a quantity of 2,500 for some envelopes. Now the unit price is $1.25 per C, which is 100, per 100. So in fact, what we need to do to calculate this extension is to take that quantity of 2,500. Whoops, I'm noticing that my grand total function is on. Let's just clear that grand total function. There we go. I'm going to tear that off and we're going to start over. Grand total is disengaged. Okay, so because this is dollars and cents, I'm going to leave the decimal at 2. So I'm going to take 2,500 times $1.25, but because the price is per 100, I then need to divide it by 100 to actually get my extended answer of 31.25. Let's take a look at the next one. Again, 2,500 is the quantity times 1350, but this is per thousand. So I need to divide that by 1,000 to get my extension for this one. So this tape demonstrates how we deal with extending items that are priced by grouping. In this case, by hundred and by thousand. Hi students, this video is on lesson 20, auditing invoices. I'd like you to turn to page 124 and take a look at the invoice there that the demonstration problem audits. Generally, the way that we would audit this invoice would be to use the grand total function. So I'm going to engage that, have our decimal set at 2. And the first thing I'm going to test are the extensions. So I would take 6 dozen times $15, comes out to be 90. That agrees with the invoice. I'll test the next one. 12 times 60, that also agrees with the invoice. 7 times 950, that agrees with the invoice. And then 3 grams times the price of $7.20 per gram, we end up with $21.60. Again, we're in agreement, so we just place the check mark there. But when we do the final extension, 6 times $11.95, notice that we come up with $71.70. That means that that particular extension was incorrect. So when we press the grand total here, our grand total is $969.80. That's going to differ from the invoice, of course, because that last extension was incorrect. So let's go ahead and compute the rest of this invoice because we know it's all going to change from here on out. So we have that amount as the total. We know that there's a trade discount of 10%. So let's go ahead and calculate that. We're going to take that amount times 10%. We're going to subtract that 10%. We now get a new net price. That net price then is going to, in fact, get charged 5% sales tax. So we're going to take that amount times 5%. That's going to get added, okay? So our new amount due would be $916.46. This would be how we would audit that particular invoice.